Yeah. So what is what are the LLM orchestration tools? So, like very broadly before we answering that. And I'm calling orchestration everything from LangChain to Llama Index to Auto GPT, and like all the big frameworks which aim to help building AI applications, be it by orchestrating calls in terms of prompts, be it I don't know, providing single interface to different LLM providers, all of that. So like loosely defined one. And let's read how those libraries, orchestration tools define their like slogans. So LangChain, the first one, build context-aware reasoning applications. Llama Index is about a data framework for your LLM applications. Again, yes, for the building the applications with that. And the AutoGPT is this the like really strong one, is the vision of acceptable AI for everyone. Yes, so that you can build on. Our mission is to provide the tools so you can focus on what matters. So all of them, they are allowing this infrastructure to build applications. It's like a programming language in a way. And what we can see is that a lot of them are focusing on essentially data. Data framework context is again data is being in a prompt or in rags. And what's notable actually in all of them is that even AutoGPT, which started as agent framework, they are not really mentioning it. And so that's actually one of the major underlying issues. So for me to start asking this question, if there is a place for orchestration tools, because what we have when building those tools is that on the one side we have the complexity of trying to suit application building, which means that it has to be very generic. It might be applications for, I don't know, for writing, for accountancy, for all sorts of analytical applications, whatnot, everything. Yes, we are building it. It has to be generic. So that's one side, which introduces very big, requirements of figuring out abstractions which are suitable for this broad range of applications. Of how are we using that? So that's one side. But then on the other side, we have the AI LLM, which is what it's already 3 years, which are already hitting big time, and it's constantly changing. So it's the OpenAI, Cohere now, Anthropic. They are constantly releasing some new stuff. It's constantly improving. So it's another kind of another moving target for those tools, which you have to hit. Yes, so on one hand, the moving targets of applications, okay, where you are going with that, and another moving target is the LLM, underlying technology itself. So dealing with those two things is quite challenging, and that's what I'm showing LangChain and AutoGPT and others. But that's exactly what I'm trying to do with Bosquet. Figuring out those abstractions and what can be helpful for application builders. So my goal here in this talk is to go through the functionality currently provided in Bosquet. I will touch upon some unimplemented maybe functionality, and we'll try to kind of reason and think about, okay, is this necessary? Is this functionality helpful for the applications? Maybe it can be, crossed out, and we end up with direct calls to LLMs, and tooling is not really necessary. And yeah, I'm not really sure, because as I said, it's a constantly changing bleeding edge of moving targets, which is quite hard to keep up with. Yeah, so I'm starting with user guides. This is all accessible through GitHub repository of our documentation. I will not be going into too much detail. My goal is again to kind of highlight the main points in functionality and kind of argue that probably all of them are needed when building that layer of integration with LLMs. The question is what's the right way to implement it? Yeah, so first of all, we need to configure the calls to LLMs. Yes, when I was starting with, it was 2023 Christmas break, when LangChain was hitting the first thousands of stars. All we had in terms of configuration was just, you provide your API key to OpenAI and that's it, and you don't need anything else. But then the provider started growing. The other parameters needed to be passed in, and what I was ending up with is this. Actually, I will show it here in Emacs, the whole thing. So you can see supported calls to different providers like OpenAI, Olama, LM Studio, Mistral. All of them essentially are just pointing here both chat and complete functions, which is like interface implementation. Also, default parameters and this from the configuration taking OpenAI endpoints and secrets. So all of those are kind of following the same pattern, except here you can see that in Olama I have also defined embedding endpoint. It is not defined in OpenAI simply because it is not really implemented, but would be easy to do. So the three things like, okay, so how do we pass in complete, chat, and embedding functionality in whatever we do? So those are readily Cohere as well, readily available in Bosquet. And the history here was as well that this not really knowing what is the LLM service. Is it a standalone component with state? So and one of the versions I had that this configuration was done with Integrand and would pass in and construct web services, which proved to be quite cumbersome from some of the users who are using open source version, open source library. It quickly became apparent that people want to change to introduce their own configurations, and I will show you how this is done. So this is one of the requirements, I think, for any kind of LLM application library, is that you are not really using one provider or one model. You want to, in sufficiently complex application, you will be switching between between Olama for embeddings, between the GPT-4 for something requiring reasoning, and something else for Cohere for different tasks, and kind of all of that can be composed. So this configuration layer, which hides the the complexities of how to deal with that, is important part of the framework. We talked about the ecosystem. I was kind of saying that we are lacking ecosystem for the LLMs, but it might not be really huge problem, because we can use other components available, not directly LLM related. Like even in the configuration, if we have some more complex configurations here in how to define the LLM calls, how to define secrets and override default behavior. The ARA library is an amazing tool to do that, which I'm using. So this is good thing to have. Yeah, so this is the components we are supporting. But it is possible to define again your own. I will have a section of that. Yeah, so once this is ready, we can actually generate the completion. So I have very simple call here, generate, simple reasoning task, okay, mathematical, and we get the response. But it's a lot of happening here. So what is the, who is making this, which model is making actually this course? If I go to generator, yes, to some of the examples, if I will call something more simple, let's do some named entity extraction from the Lithuanian text. See here, it is calling Mistral. So what is happening here? Why it is Mistral, not something else? Is that it is also in configuration. I think, yeah, here, yeah. So default LLM, model Mistral. So that's how it is done. So that through the configuration we can get that. And I have again command line tools to manage those things, but I will not be touching on command line here. Yeah, so this is that. So we can define default parameters, which is, yeah, why this is also kind of important from practice is that when you're building LLM applications, you're experimenting a lot. It's not like writing an algorithm. You would tweak, I don't know, a word here instead of age, years, or something like that. And you really want like quick access to this. You don't want to specify as a parameters additional things like, okay, which model to use. You really need some quick access. So keeping somewhere defaults so that it enables you to experiment without any hassle is quite, again, useful feature for the LLM application building and framework for that. But this will not get us far. Yes, it's just simple completion. So Bosquet provides a tree implementation. So we're all familiar with chat, where you sequentially provide your discussions with LLM. Here, what we can do is kind of define a tree of dependencies between various components of my prompt. And here is another like infrastructure Clojure provides through Python, because I can now in my just simply map say that, okay, a question, this piece of prompt depends on question, depends on answer, and I don't care what it is here. Yes, I can just say, okay, well, those are my dependencies. And somewhere else I'm writing, oh yeah, but the answer is actually LLM generation with a configuration like that. And question is actually coming in as input data in the other map. And that when I want to evaluate this question, I don't really, again, care what was above. I will just write, okay, for my evaluation of the answer, I say, okay, get whatever I've got here in question answer. So in this case, I will get everything filled in, and the evaluation will be done with a different model here. It's GPT here, and that's with Mistral. So in one go, with Python, I will get the resolution of dependencies and two different calls. So here in this, why my mouse has died. Okay, interesting. Yeah, so I will get the those two, yeah, the whole data. Yeah, so this is the answer, the average distance generated. That's a question coming in, question answer. And we have like the whole complete generation here. Yes, with the LLMs filling in the details. Yes, so all of that was happily resolved, and we don't really need to worry about dependencies here. And that's, I think, one of the more unique things Bosquet is providing is this this tree resolution. And I will go deeper here because this is also one of the challenges I'm struggling while probably even failing to properly implement. But I will go into more details because understanding what's the execution plan here is not that trivial. Yeah, but still, so this is one of the other like ways how to do that. Another point why I was implementing this tree-based solution here, prompting, is, yes, one is that I can independently define my prompting components, Yeah, so even kind of in different individuals can say, okay, well, some will focus on question answering prompts, and others will focus on evaluation. But also, if we have agents, or just not necessarily agents, somewhere mid execution, mid resolution, I can swap some of the parts here. I can say, okay, depending on the answer, I can then install, call self-evaluation or do something else. So yeah, so this kind of dynamic construction of this tree is one of the motivations to have. And yeah, so this is, if going back to this question, if there is like, can LLM tooling provide something valuable for the API builder, application builders? That's this, I think, because then with something like that, people can focus on just like components and don't care about resolution of the whole complex tree of like, it's in a way how to execute the program. Yeah, so few other interesting bits here is that, yeah, we get some statistics like how long did it take to execute it, and well, the counts and prompts, prompt tokens. So per generation, so one is for answer here and one is for test here. Right, so this is one. And yes, so that. Also, just quick illustration that if I define my prompts like through the partial, like generate, and I pass in my defined prompt, I can then create this kind of processing of my multiple questions in one go, even in parallel, like pass it into whatever parallel processing tooling you have, so that you can get question answers at once for multiple questions. Again, you will get the same responses here. Right, and quickly, before a quick peek at questions, if we have one, is chat completion. Yeah, so this is something we are used to. Okay, in Bosquet, the same generate function. See, it's always generate. Yeah, so we can understand what's happening. If it's a string, it will append the default generator. If it's a map, it will know what to do. And if it's a chat, it will know how to execute it. So you're an amazing writer, generates a title and genre and then synopsis and critique for that. So what will happen is that it will execute assistant till the generation of synopsis here. Note a difference in LLM definition. But this is LLM function, but what you have here is nothing fancy. It's where is my LLM? Yeah, here, LLM. If I do this, it's just a simple map, you see. So it's a helper to create a map, nothing. No, it's not like a function call here. Yeah, so the only difference from tree definition is that in tree, we get variable name here, answer. I know that whatever will be generated here, it will be assigned to answer. In chat completion, I need to kind of name it. So this generation will be assigned to synopsis, and I can refer to the synopsis somewhere down this chat prompt. So I'm not showing it here, but for example, this user somewhere down might refer to synopsis. I can reuse it again. Yeah, but this is it's not that relevant in chat messages, because still you get the whole context available. But yeah, it's here, and the same for critique. So what we get here is that we get the whole structure for conversation. Yeah, so we can see what's happening here is that what the whole conversation was. Here we see the data filled in. Here we have whatever LLM has generated for a synopsis of the play. Yeah, the world of technology rules it all. Yeah, it's about technology because it's science fiction. And then we have ask for critique, and we get a critique for that. And as expected, also the token usage. Yeah, so this is the 3 different prompting techniques, which depending on the application and the use, might be, might provide value for building building your application. I think, well, chat is the most common, and there's probably not that much additional input here. You can use it directly, LLM providers, but tree is quite, I think, useful in terms of implementing more complex flows. Yeah, so we'll pause for a question if there is something available. Yeah, oh, good. So I'll just continue.
We don't have any questions so far, so yeah.
Yeah. Yeah. So again, against myself, which I mentioned early on, that yeah, we kind of lack maybe LLM infrastructure, but we do have a lot of amazing tools to build LLM environments. So Selmer templates is the tool for this. Okay, alongside the Paffer, which allows to resolve dependencies, but Selmer is another indispensable tool for working with LLMs. Well, I will not be going into the whole details here. It has a lot of amazing functionality. But a few like regularly used things is that you can, first of all, if you supply as your data, some kind of collection, you can iterate through that and enumerate everything. So for batch processing is really good. So what I will do in this prompt is batch processing tweets. So we are listing tweets here. And another one is that, well, not strictly necessary, but if I want to say that this is kind of trying to make it generic, it's not just about tweets, but I can pass in, I know, just sentences. Yeah, so I can specify additional parameters saying text type, not tweets, but documents, sentences, and yeah, it will replace. But if I'm generally working with, in this case, with tweets, yeah, I just specify that this field will be, this without by default. Yeah, and so this is defined. And of course, I want to classify it using, in this case, Llama, locally running, yes, local, no calls. And this is the model, which model to use from Llama. Yeah, and we define 3 tweets here. And yeah, as expected, we get responses. So here somewhere, like, where was, no, here, classify. Yeah, here. For some reason it's not expanding, but anyway, so this is the list of, under this one, we'll get the list of all 3 evaluated tweets. Yeah. Oh yeah, here I'm printing out. No, it's just a prompt. Yeah, but still, so this is like Selmer way of defining quite complex stuff. And again, check out the documentation, and we have like a lot of very, very relevant functionality for building complex prompts. Yeah, and Bosquet kind of integrates it fully. Previously, I had a fork of Selmer, which introduces a few LLM specific functionalities, but then I found that they are not that necessary, and it's better to have less like custom dependencies and just use Selmer directly without custom changes. Yeah, so that's the introduction to the Selmer. And the last bit with the configuration is that, yeah, we might not be happy with whatever is provided by default in LLM tooling. That is, whatever I have here, yes, it might not be sufficient. And you want to specify some, I don't know, really custom LLM calls. Yeah, so all what is needed is that you specify here. That's the example. Like say, in this case, it's LLM, which is so stupid, it just prefixes a message to whatever is passed in. Yeah, so I can define, like in this environment here, yes, it's nothing but the map from the ID to configuration. Yes, nothing really fancy. So I do the same. I say that that's the prefixer, the name, and its chat function. It's not necessary to define embeddings and completions. This chat is enough if you will be calling that. So it will be getting the configuration, and it will be getting, whatever is passed in, like prefix and messages here. So, and yeah, we can generate that with a new one. So you can pass in your own parameter, your own environment as the user env. Yes, and it will start using it. So yeah, here we say that my prompt is like that, text and then generator. Generator is that my prefixer, and that's the configuration for this. Is model parameters. Model parameters is this prefix 3 pipes. That's it. Yeah, so what will happen if I will pass in a fox jumps over, it will get a prefix. And that's exactly what's happening, yes. So silly illustration, but that's as simple as all you need to do to pass in your custom stuff to define a new node for the generation. And of course, you can merge with existing. So environment namespace contains the whole configuration. What I have, so Cohere, OpenAI, or Llama, all that stuff. If you merge with it, so your environment plus this will work out. So in this case, yes. First in chat, I'm calling my custom prefixer, and then I'm saying, okay, let's just add a suffix and continue over it. So with generation 2, this one will, yeah, exactly, it kind of continues further down the line. Yeah, so this is the the whole kind of work with LLM providers, and in some way, one of the things I'm kind of contemplating and thinking is that maybe Bosquet needs to be cannibalized in a way, taking out smaller subsets of it and creating independent libraries like this, what I just was talking about, like how to configure LLMs and how to call them, is all we need. What I didn't mention, for example, is that some of the LLMs like Cohere will have different naming. Like max tokens is the same, but number of generations, which is in OpenAI style, is n. In Cohere is num generations or something like that. Few other differences, and it's all kind of normalized. So you can pass in, you can think about the same definitions of your parameters, and then the mapping is done behind the scenes. So this just calling of LLMs can be just kind of the independent small library. Maybe that's the way also to simplify and to narrow to avoid this handling too many moving parts. So that's one. Caching, another kind of interesting feature which I have is that if you have exactly the same parameters and exactly the same prompt, then you don't want to hit again LLM because of its performance, both money and time. Yeah. So if you specify the cache true, this is going to be also the calls will be cached. So if you call it first, generation 1, with exactly the same thing, what is the distance from moon to Io, intentionally making it complex because both things are like moving around. Yes, and the parameters are exactly the same. Llama on Llama 2, that's 1. I will make another call with exactly the same. It will be, you will see the time here is 15, we'll be able to compare it. And the answer is exactly the same. So here we have time 6,000, and answer is the average distance is something. And of course, this, I was mentioning that clerk is having some quirks and I cannot open this one. But anyway, this is, trust me that this will be the same. Here we have a sync answer and time is 15. But now if I have cache true, but I change temperature, although the rest is the same, different. Yeah, now it's, maybe it's still somewhere, but it's the time is well, longer here. So that's the actual timings. It's actually tokens, not time. So here's the time. So yeah, we have comparable. First call 6 seconds, super fast, and kind of the same. So kind of simple functionality, but it's also kind of we talked about Python. Python has the whole library for that, just GPT cache. Because in this case, what is used is just also closure cache implementation, one of the libraries. It will check for exact matches. And yeah, it's not always what you want. You might want some more semantic approach, like almost similarity. If some of the words are changing, it's not that bad. It can still be hitting cache and then returning it. So that's another area where kind of a good rich implementation is fruitful area of value provided for the applications, because we are not always generating stuff with LLMs. Well, what we are often mistakenly thinking, a lot of tasks are just classification, like tweets, extraction. So if I have like huge load of that, and a lot of data might be repeatable, the caching is really a big saver for the improving the speed and customer satisfaction then. So this is quite critical as well to have. But again, in Bosquet, it's quite a naive implementation. I showed here, it's based on this library. You see, it's just a few lines. But yeah, making it much richer would be interesting, and justify the existence of LLM tooling for the app builders. Yeah, so another topic is and this is kind of one of those moving targets of the LLM technology, is this output format. Often we want JSON, Eden generated, booleans, numbers, like something specific, not just text. And by the time we've got something implemented here, again, OpenAI and others are releasing function calling, which is ensuring that structured output. So it's probably not that critical and not that interesting or specific to have an implementation in Bosquet or other libraries, but still it was here from the early days, and yeah, Bosquet is providing that. But again, probably it is quite efficient and best just to go with function calling, I guess, and avoid this specification. But you will have this. So what is supported is the Eden. So if I write here that, okay, I need Eden, and this is, it's not like if I specify here in output parameter that I need Eden, that it will generate Eden. You need to talk about it. And this is not something wild to require. If you look at the OpenAI documentation, where we have similar parameter about the output in JSON, they ask users to define it in prompt that, okay, I want this output. What I was thinking is that I might kind of have small library of those strings here. And if I see output parameter, some specific output parameter, I kind of auto inject this. But I kind of figure this is small magic. It's better to be explicit and leave it to the users to specify it. So yeah, if I'm writing this, I'm asking distances from the sun to planets. Result is Eden. Same here. If I want Boolean, it answers in yes, no. Yeah, here I'm answer yes, no, but I'm asking it to become Boolean, and responses in Boolean. Same as for lists, provide bullet list of 4 colors, and I'm getting a collection of the responses. And this, I don't have JSON, but yeah, same story with JSON. Yeah, so where it is, it's not just this, that I'm getting one response. When I'm starting to chain the prompts, like in that tree prompting, ability to get data in Eden becomes very good and useful, because if one of those steps returns Eden, then in further steps in Selmer template, I can start, enumerating stuff. So that's quite interesting and good value. Well, apart from function calling. Yeah, so this is surface, and I see I'm looking at the time. Yeah, so quickly, what is also provided, and again, the tooling needs to kind of give provide some functionalities. That okay, we are dealing with big texts, yeah, so we need to chunk it for RAG essentially, and so chunking can be done per character, per token, and per sentences. So it is all supported, and we can have a text. Yeah, it's probably a bit pretentious to give an example from Moby Dick, but yeah, I was reading that book at that time, so it's still here. But yeah, so when I'm defining my chunkers, I can say, okay, what's the chunk size? What's the overlap? So how much overlap there is between my chunks? And what's the splitter? Is it character? See here, it cut at W, and see watery, those parts basically overlapping, and the rest of them. So that's one. Now, if I want to use sentences, it depends on sentence splitter through OpenNLP. We have to run this BB command to download the model. And now it will start chunking per sentence. If overlap is not specified, there is no overlap basically. Yeah? So we get like nicer. And then tokens. Yes, we specify essentially a model, which model to use. And Bosquet has this issue that the only tokenizer supported is from OpenAI, because there is this Java library JToken which does this. And if we are using other models, yeah, we don't really have good alternative for that. So, but yeah, something to do. Yeah, so we have per token here, some overlapping, and what I did is that those are the results. The prompt is asking to extract keywords from those tokens. What I was trying to investigate is to see if there is any difference in using different tokenizers. Yes, character splitter, sentence splitter, and token splitter. Yes, all of them extracted keywords, and then say, okay, another summarizing prompt. Okay, just compare and see what's happening. But yeah, I think that's more or less the same. Using all the splitters, doesn't matter. But yeah, probably character splitter is just, I don't know, for some specific tasks, but you would go with sentence or token splitters. But here's again this doubt of LLM orchestration tooling, because what we have is ever increasing windows, and of course for RAG application you would still need the, it's not like you're fitting everything into the context window, but the quite strong argument is that what you want to do is not to chunk it, but like summarize by certain topic. Is okay, if I'm working on keywords, summarize it by keywords and then do something like issue multiple summarization issues. So where are like, you know, you can use tools like Vespa with hybrid search and Colbert, and then do different solutions for that. So it's kind of, I'm getting now a feeling that the necessity of text chunking is not that big, and it's probably not that important to support in LLM tooling. So it was, you know, important a year or so back, but the trend seems to be that text chunking is well, useful for something, but questionable if it's that you know, big value. Document loading. This is like, well, I have to admit here, I was just chasing after LangChain and Llama index because they had like, you know, always point to your folder of documents, PDFs and whatnot, and we'll load it. But so I have this integration here, but it's all it does is just calling Apache Tika library, Java integration. Again, the reference to the ecosystem provided by Clojure. Yes, so although we don't really have that much of direct LLM, but we have very rich access to all sorts of tools which we can employ for LLM work. So with this simple call, be it PDF or Excel, you can get your text and, you know, chunk it if you want, pass to anything like a big context windows, index it somewhere else. Yeah, so this, I don't know, I'll quickly peek if we have questions. Nope. Right, so few last topics here. I will skip observability. There is a recently recorded video how to make how to observe which prompts were sent to applications. Memory use. So very quickly, we need to build RAG applications. We need access to vector stores. So I have here Quadrant implementation, like support for that. The task here, okay, we have pro-social dialogue in which just basically has a list of in this, well, not nice messages and how to fix it. So if someone is trying to communicate something wrong, we can find rules of thumb how to fix that response. Yes, so all of that, it's 40,000 or so in that pro-social dialogue messages, and all of that can be used to go to index into vector database, and then we can find based on the message. Yes. By the way, this is a small library I implemented. I mentioned as well this Hugging Face data set. So you can use Python tools for to download and cache locally data sets, but this small library is also doing that. So if you download it once, every time it will come from your cache. So yeah, what I'm doing here, I'm indexing the whole thing, about 40,000 messages. I'm supporting here short-term memory and long-term memory. Short-term memory is just basically inside Atom as a rememberer, so something to remember your messages, and recaller is to recall. And what's happening here is that I'm encoding it with for this short-term simple memory, I'm using another is that simple memory? Yeah. So it just uses cosine distances. Again, not recommended to use anywhere close to production. It's for the quick development, so I can in memory kind of quickly compare strings. But long-term memory goes into Quadrant. You can specify configuration. You specify embedding here from Llama. Again, the same remember and recaller. And we can kind of remember committed to memory. So I can show it quickly in Quadrant here. So we have points. Yes, it's all those things, rods and then save it annotations. Everything is in here. 42,000 messages here. And now we can use it. So my post is, I've got something stupid for Christmas. And then I can ask, my model here in the chat to inject whatever was found matching. Yes, the message above is potentially harmful. If I have safety reasons, just paste it in. Yes, here, and then it will kind of can incorporate it. And sorry, I'm kind of rushing now, looking at the time, but yeah, that's what we get. So that's what we are receiving it from this pro-social dialogue, and then a system can suggest to the how to fix it. Yes, and that's for short-term memory, and that's for long-term memory. Like two examples. So yeah, this is going to be going into the RAG area, and yeah, again, the question is that on one hand, if I'm building just purely RAG application, maybe purely the RAG tooling is sufficient, but then on the other hand, for the RAG application, I really need all that complex prompt building techniques, and so it kind of emerges together. So yeah, it's not like we can. So when we are building those apps, AI apps, we are building it with the full range of complexity. So we need caching, we need calls to different LLMs, we need RAG elements, everything. So yeah, it's not that easy to just pick and work with, I don't know, a collection of small libraries. So it kind of asks for this complex unified LLM orchestration tool, which would help you build those apps. Yeah, so that's it. Just quickly, for if anyone wants to brainstorm and help me out, what I'm having a big issue with is this. That in tree prompting, when I am defining complex tree prompts, I need to figure out which branches of a tree can be executed in parallel, which branches are in isolation, what are the dependencies. Pathom helps here, but it's not that easy. I really need to kind of understand, and really goes into this complex computer science area. Figure out how to process computation graph with added complexities that dependencies might arise in middle, depending on generations and you name it. So by the way, this is also a good example where I have dependencies with here Eden and second steps are rendered. But yeah, so help needed with figuring out this LLM execution generation graph computation, because I'm kind of figuring out one case, but then it falls on the other, so I don't really have good generic solution. Yeah, so I'm done. Yeah, rushing a bit, but